Hi, this is Shuyan and I'm glad to give you my presentation. The topic of my project is face recognition in color images. This presentation will be divided into 5 parts. First, introduction to the face recognition area. Then talk about the skin filter, how to use it, and the result of mine. The third is face detection from skin regions. So here we'll come to more results. And the fourth part is the related work about my project. And finally, I will give you my conclusion. So, a number of research groups have already been designed to locate the person in the image of face systems. That is what we said, the face recognition. And we should now detect in the project for face. It's based on 2 steps. First, the image is filtered so that the only area of skin containing human can be labeled. With the filter in MATLAB, you can use basic math function and image processing design to define the face area on the skin filter. The changes of filter algorithm were made to provide improved subject and output. The second stage is to make an area of skin and remove the darkest and the brightest area of the map. Though entirely removed testing area, usually the removal of the face eyes, eyebrow, nose, and mouth area. In this way, we can step by step to detect and recognize a face in a picture. This picture of this man with his golf in his hand is the picture I used as texting in my project. So the first thing I will do for this picture is give it a textual mapping. A textual mapping is generated from the matrix I by these steps. First, media filter I with a window of length 8 plus scale on a side. Second, subtract the filtered image from the original I matrix. Third, take the absolute value of the differences and medium filter the result with a window of length 12 multiply scale on a side. And then we will give this picture a hue and a saturation. It's also kind of improve to the picture. We can see the hue opponents from the log conventions here, and the opponents from the log is converted to stature unrespected is here. And I want to see hue and the statures are all made to choose those areas of their skin color matching. Restrictions will only use of multiple texture hue and striation. Then we'll finally get the skin map we need. So maps can build as an iron of skin, and skin areas appear white will be valued of 1 and black into a binary image. The binary operators and skin explanation disk structure elements used to expand map area. This provides a way to enlarge the area of skin map with skin background border pixel or other characters of the area close to their hair or reduce the stature region. And here is the 4 pictures has been improved by the method I mentioned above. The one on the left and the top is the first one I mentioned, is textual map. So it's like what we said, it provides the texture of this human. In the top right one is the who image. The who image is about to choose an area of their skin color. So we can see that the face and the hand are really have different kind of color of other areas. And the left downside is the stillation image. It also has the same way about the who. And the right down one, the black and white one, is the map image we need to get. And in this one, we can clearly see the white part where is the man's arms and hand, and that's the skin part in this picture. So it's kind of successful for this project. Then it comes to face detection from skin regions. And the first one I will mention is to have a grayscale image. It's important to make sure that the binary skin map consists by solo regions. The closed cell skin map is really important because after the program makes sure the holes are found after those through-hole operation, structure of the optical disc 3x3 picture elements in the skin with a hole solved by a map of the execution, and then the image is multiplied by the original image garden convention. And then we will have the positive and negative images. So there is a comparison of them. In the positive image, and for actually most of the test image, we will have the positive image. This through-hole work quite well. The binary image created by the through-hole is then passed through a connected component labeling to generate a positive image showing distinct skin area. But also there may have some negative images. A negative image is next generated that will show only holes as objects. Hole closing of the binary image generated by the through-hole operation is performed with a 4x4 disk structuring element. And here is the 2 pictures of the positive and negative image. In the positive image, we can see there the man's face, and you can even see the holes of his eyes and eyebrow and nose and even some mouth. But in the negative image, you can barely see nothing. And I have 2 related work about this project. The first one is the algorithm of face detection based on skin color. First, face detection are improved really fast in the latest year. And the most traditional face detection is based on brightness space, and it ruled the world. This way really rule this work. So in this project, they focus on to use under color space. the skin color distributed of different races is clustering, which can be used to detect human faces. And the second related work is face detection based on the physical model of a color image. So first we need to know face detection is to detect whether there exists a face in a given image or video, and if present, to determine the position and size of each face. But actually it's really hard to automatically do the face detection in computer, although it's really easy for human being. So according to the positional relationship of face and hair, they defined a blue detection method of the full content and half content, which solved the problem of how to detect the face. This is really interesting actually. Here comes the final conclusion. First, because this project is only relies on finding holes in through-hole objects, there is a greater chance of finding faces regardless of the perspective. And then, when a face occupies a large portion of the image, and reasonable performs on those images, depicting people as part of a larger skin. Images in which people appears apparently poses tender will result in a very large skin map. That is maybe because that kind of close tender looks really like our skin, so it leads to this result. And this is all about my project. Thank you for listening.